Dear students, today we can study redox reactions. Let us see what is redox reaction. Redox reaction means reduction plus oxidation. Reduction plus oxidation, redox reaction. So before that, we can see what are this oxidation and reduction. Oxidation, addition of oxygen or removal of hydrogen. So oxidation is the addition of oxygen. Addition of oxygen or removal of hydrogen or loss of electron. Loss of electron. Similarly, reduction. Reduction one addition here removal of oxygen. Removal of oxygen or addition of hydrogen. Addition of hydrogen or gain of electrons. Gain of electrons. So these are the three definitions in terms of oxygen, addition of oxygen, in terms of hydrogen, removal of hydrogen, in terms of electron, loss of electrons. But in the case of reduction, in terms of oxygen, removal of oxygen, in terms of hydrogen, addition of oxygen, in terms of electron, gain of electrons. Now consider this reaction, copper plus oxygen gives copper oxide. What happens to copper? Copper changes to copper oxide. So this is oxidation. Addition of oxygen is oxidation. Now, consider this reaction. That is, copper oxide removes oxygen to form copper. So, removal of oxygen is reduction. Removal of oxygen, reduction. Now, what happens to hydrogen? Hydrogen changes to H2O. That is addition of oxygen. So, this is oxidation. Oxidation. So, in this reaction, oxidation and the reduction taking place together. Say, let us write one more time. CuO plus H2 gives Cu plus H2O. Now, copper oxide changes to copper. What happens to copper oxide? Copper removes oxygen. Removes oxygen means reduction. So this is reduction. Then what happens to hydrogen changes to O. Oxygen is added. So this is oxidation. Now, in this reaction, both of reduction and oxidation taking place together. So this is an example of a redox reaction. Now, let us see what is copper oxide. Copper. What is the role of copper oxide here? Copper oxide itself produced, but it gives oxygen to hydrogen. So this is called oxidizing agent. So oxidizing agent cause oxidation. Cause oxidation. Oxidation agent cause oxidation, but itself undergoes reduction. Here what is oxidizing agent? Copper oxide is oxidizing agent. Next, which undergoes reduction? Copper undergoes reduction. Who causes reduction? Hydrogen. So hydrogen is called the reducing agent. Reducing agent. Reducing agent cause reduction. Cause reduction. Itself undergoes oxidation. Okay. Who is the reducing agent here? H2. H2 is the reducing agent. So oxidizing agent cause oxidation, but itself undergoes reduction. Copper oxide reduced to copper, it is oxidizing. It has oxygen to give, so it is oxidizing agent. Now reducing agent absorb oxygen, or it take itself undergoes oxidation, take oxygen. So This hydrogen is reducing agent, copper oxide is oxidizing agent. That is oxidation and reduction and the redox reaction. Now, let us see some oxidation reactions in our daily life. One is corrosion. What is corrosion? Destruction of a metal by the action of environmental conditions. Environmental condition means air and moisture. Air and moisture. These are the required for corrosion, conditions required for corrosion, air and moisture. Three examples of corrosion. One is the rusting of iron. Rusting of iron is when iron particles are exposed to air and moisture, it undergoes oxidation and a layer of oxide is formed. That layer is hydrated ferric oxide or rust. Chemical name of rust is hydrated ferric oxide. That is Fe2O3 XH2O. Chemical formula is Fe2O3 XH2O. Another example is the tarnishing of the silver. There is formation of black coating on silver. Here silver sulfide is formed. That is also an oxidation reaction, oxidation of the silver. Next one is the verdigris. Verdigris is copper green coating on the surface of copper. That is verdigris. These are three examples of corrosion. Next is rancidity. Rancidity is when fats and oils are exposed to air, it undergoes oxidation. That is, it gets bad smell, bad taste. That is, food items made of fats and oils when exposed to air, it undergoes oxidation and bad smell and bad taste is produced. That is called the rancidity. Rancidity can be prevented by keeping the food items in airtight bottles or in refrigerator or in the case of chips and such items we can flush nitrogen. Nitrogen gas is flushed in the packets of chips, etc. Made oily food, nitrogen is flushed. Thus, we can prevent rancidity. So, corrosion is a destruction of metal. It can be prevented by oil, grease, by painting, by coating, plastic coating, then cathodic protection, then making alloys, etc. Also, we can prevent corrosion. Rancidity can be prevented by the airtight containers, refrigeration, then flushing nitrogen, etc. Inert gas. Now, these are the two terms we have to study: exothermic reactions and endothermic reactions. We already studied. Now, exo means out. Exo means out, and therm means heat. That is heat out. Heat is liberated. The reactions which takes place with the liberation of energy or heat is called the exothermic reactions. Two examples here. Three examples here: burning of coal, carbon plus oxygen is carbon dioxide plus heat; burning of natural gas, CH4 plus O2 gives CO2 plus H2O plus heat. That is natural gas is methane. When methane burns with oxygen, carbon dioxide and water, at the same time this heat is also produced. This equation is not balanced. CH4 C hydrogen 4, so put here 4, oxygen 2 plus 2 4. Now the equation is balanced. This is burning of natural gas. Next one is the respiration. Respiration, we know energy is released. So this is the example of exothermic reaction. Respiration, glucose burns with oxygen, combines with oxygen forming carbon dioxide and water and release energy. Now equation balance the equation. C, then 12 hydrogen, oxygen 6 plus here 12 plus 6 18. So 12 plus 18. So these are exothermic reactions. Next is endothermic reactions. Endothermic reactions absorb energy. Absorb energy. The reactions which absorb energy, one is heat. One is absorb heat. Here light is absorbed. Calcium carbonate CaCO3 absorb heat and decompose to form calcium oxide and carbon dioxide. This already we studied under decomposition. Now it is absorb heat, so it is a absorption of heat is an endothermic reaction. Here light is absorbed. A silver chloride absorb light and silver and chlorine form. This is also decomposition in presence of light. At the same time, it is an endothermic reaction. So these are the different types of reactions. So thank you.